$1 trillion. That's not revenue. That's not market cap. That's how much companies are ordering from NVIDIA through 2027, doubled from last year. Jensen Huang just delivered the biggest GTC keynote in history. And what he revealed changes everything about AI, gaming, self driving, and even space. Let me walk you through every major announcement.
This flywheel is now accelerating. The number of downloads of NVIDIA libraries is incredibly accelerating. It's at a very large scale and growing faster than ever. This flywheel is what makes this computing platform.
Let's start with the star of the show, Vera Rubin. Named after the astronomer who proved dark matter exists, this GPU is the most powerful chip ever built. 336 billion transistors. That's 1.6 times more than Blackwell. It's a dual die design built on TSMC's 3 nanometer process. Each chip packs 288 gigabytes of HBM4 memory with 22 terabytes per second bandwidth. For context, Blackwell maxed out at 8 terabytes per second, so Rubin nearly triples that. Inference performance 50 petaflops of FP4 per chip. Training 35 petaflops. This is a generational leap, not an incremental upgrade.
Where you mostly monetize your service, it increased your throughput by 35 times. This is no different than any product that every company makes. The higher the tier, the higher the quality, the higher the performance.
But here's where Vera Rubin gets truly insane. The NVL72 rack packs 72 Rubin GPUs and 36 Vera CPUs into a single system. 1.3 million components total. The number that matters? 3.6 exaflops of FP4 inference compute. That's more raw AI power than most countries have access to. 20.7 terabytes of unified HBM4 memory, 260 terabytes per second of NVLink 6 bandwidth. And here's the kicker. The Vera CPU alone has 227 billion transistors, 88 custom ARM Olympus cores, and 1.5 terabytes of LPDDR5X memory. This entire platform ships second half of this year.
Takes the pressure off of the data center, takes all of that cost and all of that energy that's used to cool the data center and makes it available for the system. This is the secret sauce. We're the only company in the world.
Now here's where GTC got truly unexpected. Remember when NVIDIA acquired Groq for $20 billion back in December? Everyone wondered what would come of it. The answer is Groq 3, a language processing unit that completely changes the inference game. Instead of GPU-style parallel compute, the LPU uses 500 megabytes of on-chips RAM with 150 terabytes per second bandwidth. The result? 35 times more inference throughput per megawatt than GPUs alone. Jensen called this his Mellanox moment. And if you remember, Mellanox turned out to be one of the best acquisitions in tech history. A single Groq LPX rack holds 256 Groq 3 chips, delivering 40 petabytes per second of bandwidth. For trillion parameter models, Jensen says this opens up 10x more revenue opportunity.
In the pipeline, so that we could put the work that makes perfect sense on Vera Rubin and then offload the decode generation, the low latency, the bandwidth limited, challenged part of the workload.
Jensen made a bold claim, quote, "The ChatGPT moment of self-driving cars has arrived." 4 major automakers signed on for Level 4 autonomous driving using NVIDIA's Drive Hyperion platform. BYD, Hyundai, Nissan, and Geely, plus Isuzu for commercial vehicles. But the headline deal is Uber, fully autonomous robotaxis with no safety driver, launching in LA and San Francisco by the first half of 2027, then expanding to 28 cities worldwide by 2028. NVIDIA also released Alpamayo, their autonomous driving foundation model, as open source on GitHub, along with Cosmos world models for AV development. The self driving race just shifted from if to when and where. 110 robots were on the GTC show floor, but only one stole the show. Disney's Olaf from Frozen literally walked on stage with Jensen, a fully autonomous, free roaming robotic character. No tethers, no remote control. Trained entirely through deep reinforcement learning in NVIDIA simulation, Olaf learned to balance on a moving boat in just hours. It debuts at Disneyland Paris on March 29th. Beyond Disney, NVIDIA launched the first healthcare robotics platform. OpenEdge is the world's largest healthcare robotics dataset, 776 hours of surgical video. Johnson & Johnson MedTech, Medtronic, and CMR Surgical are already building AI-powered surgical robots. ABB, Universal Robots, and KUKA are also on board for industrial applications.
Newton works! Wow! Omniverse works! Olaf, how are you?
I'm so happy now that I'm meeting you.
I know, because I gave you your computer, Jensen.
What's that?
Well, it's
DLSS 5 might be the most controversial announcement of the entire keynote. Here's what it does. It uses AI to completely re-render game graphics in real time. Not upscaling, not frame generation. Full neural rendering. It takes the game's color output and motion vectors, then generates photorealistic lighting, skin, hair, fabric, and translucent materials. Jensen called it, quote, the GPT moment for graphics. But not everyone's celebrating. A vocal group of gamers is calling it a Snapchat filter layered on top of developers' work, arguing that AI is overriding the art direction that studios spent years crafting. Bethesda, Capcom, Hotta Studio, NetEase, Tencent, Ubisoft, and Warner Bros. Are already on board. First titles include Resident Evil Requiem, Hogwarts Legacy, and Starfield, launching fall 2026. This one genuinely sounds like science fiction. NVIDIA is launching AI computing platforms into actual orbit. Vera Rubin Space One delivers 25 times more AI compute than H100 for orbital inference, running large language models and foundation models directly in space. Partners include Etherflux Axiom Space, Kepler Communications, Planet Labs, Sophia Space, and StarCloud. Think about what this means. Instead of beaming raw data down to Earth for processing, you can run inference on satellite imagery, weather patterns, and communications data in real time right in orbit. If you thought supercomputers only lived in data centers, think again. DGX Station is NVIDIA's most powerful desk-side supercomputer. It packs a Grace Blackwell Ultra desktop superchip delivering 20 petaflops of AI compute with 748 gigabytes of coherent memory. This machine can run trillion parameter models locally. No cloud, no internet, completely air-gapped if you want. Available from Asus, Dell, Gigabyte, MSI, Supermicro, and HP. The catch? 6 figures. But for enterprises that need AI inference without sending data to the cloud, this is a game changer. Ships this year. NVIDIA also made a major play in the agentic AI space. NemoClaw is a new enterprise-grade open-source AI agent platform with cybersecurity guardrails and privacy controls. It's hardware agnostic, doesn't even require NVIDIA GPUs. They also launched the Nemotron Coalition, a global collaboration for open frontier models with inaugural members including Mistral AI, Perplexity, Cursor, LangChain, and Black Forest Labs. The first project, an open base model co-developed with Mistral, trained on DGX Cloud. NVIDIA now has 6 model families: Nemotron for language, Cosmos for vision, ISAC GR00T for robotics, Alpamayo for driving, BioNemo for biology, and Earth-2 for weather. The cloud partnerships announced at GTC are staggering. RBS is deploying over 1 million NVIDIA GPUs globally, starting this year. Microsoft Azure is the first hyperscaler to power Vera Rubin NVSM2, with hundreds of thousands of liquid-cooled Grace Blackwell GPUs deployed in under a year. And then there's the 2028 roadmap. Feynman architecture, named after the legendary physicist. Built on TSMC's A16 1.6 nanometer process. It introduces silicon photonics, optical signals replacing electrical ones for interconnects. Performance? 14 times Blackwell. The Feynman generation scales from NVL1P4 to NVL1P2. That's over 1,000 GPUs in a single system. Rosa CPU replaces Vera, and a new LP40 LPU joins the lineup.
Fiber CPO scale up. So for the first time, we will scale up with both copper and co-packaged optics. Okay?
Let's recap the numbers that matter. $1 trillion in orders, 336 billion transistors per Rubin GPU, 3.6 exaflops per rack, 35x inference advantage from Groq 3, 28 cities for Uber robotaxis by 2028, 110 robots on the show floor, 25x space compute versus H100, 20 petaflops on your desk, 14x performance jump with Feynman, over 1 million GPUs deployed by AWS. GTC 2026 wasn't just a keynote. It was a declaration that NVIDIA intends to power every layer of computing, from your desk to orbit. If you found this useful, hit subscribe. I cover AI news and breakthroughs daily. See you in the next one.
Fundamental inflection. Finally, AI is able to do productive work, and therefore, the inflection point of inference has arrived. AI now